Hello, and welcome to this very basic intro to Grasshopper and to your first assignment, which is building trusses, very basic trusses. So when you open Rhino and you just type in Grasshopper, you'll be greeted with this window here. And on the bottom here are your last few recent projects, which you can have open very quickly. If this is your first time opening Grasshopper, then you may have something different here. So you can begin working in your canvas immediately. So you can just double click anywhere and search for components. So for our truss assignment for this example, I'm going to be creating 2 points. So one here and one here. These 2 points will define basically the endpoints of our truss. So if we look at the trusses poster, we're going to be building the lenticular truss, which is, in my opinion, like a very simple and basic truss to make in Grasshopper, and it goes over a lot of the concepts, like the basic concepts that you need to understand. So the 2 points that we just created are going to be basically the endpoints of our truss, and the first thing we'll do is we'll create the top and bottom chords of the truss. So to do that, first of all, let's import these points into Grasshopper, and we can just simply type in point. So we can search for point by clicking anywhere, or if you hit the spacebar on your keyboard, you can search for components built into Grasshopper. Also, if you have plugins installed, you can search for them here as well. So first component I want is the point, and I can click and drag these around. If I wanted to create another one of these, instead of having to type point once more, I can, while I'm dragging, if I hit Alt on my keyboard, I can create a duplicate. So right now they're orange because there's nothing inputted into it. So it's like basically it's looking for data to work with. So if I just right click and set one point, I can select this point here. I'll select one more point and set that point there. Next up, I just want to create a line that goes between them. So again, if I just double click anywhere, type in line, there's actually two line blocks which have the same name but have a different icon. This one is just a reference to a line. This one is actually the component that creates a line from these 2 points. So we imported points into it. If we wanted to connect them, all we need to do is literally just connect the points into the start point and the end point, and we'll have ourselves a Grasshopper line, which doesn't exist in Rhino geometry yet, but it is here and you can see it inside Grasshopper. The next step would be, if we look back so we have this line that goes through the center. To create these arcs, we need a point in the center that is raised on both sides so that it's symmetrical. To get that point, we can use this component called point on curve. So if I search for that, I'll have to do a little bit of searching, but this is the one we want, point on curve, and you just simply connect the input. So if you notice this, you can treat this as a slider that goes from 0 to 100%. So this right now is at 50, so we have a point. If I select it, you'll see a point exactly at the center of this line. If I move this around, we can move that point around. Again, to reset that, I just right click and hit half or mid. Next up, I want to move this point up and down. So inside Rhino, you'll have this little axis icon over here in the little corner, bottom left. X is this way, Y is that way, and Z is up and down, okay? We want to move our point in the Z direction, which is up and down. So first of all, we need to put in a move component so that we can actually translate our geometry. This requires the geometry that we want to move and also the direction that we want to move our geometry in. So we can immediately drag that into our geometry because we want to move this point. And by default, there is a vector set which is 0, 0, 10, so it's 10 meters in the Z direction. So if I click this, you'll see that it created a point randomly, well, not really randomly, it just created a point up here, 10 meters above our original point. We want to define that point better, so we just first of all type in unit z to get that unit vector, which is in the z direction. We connect that. By default, the unit vector is at 1. So now this point that the move created is actually 1 meters above the point. So to control how much we want to move up by, we have to bring in a number slider. And a number slider is, you can just type in number slider, and you can see that it creates a number slider for you. If you wanted to increase the limits, you can do so just by double clicking on the name. You can also set it to be just integers or real numbers between certain decimal points. Another way to create a number slider is simply by setting the limits and the default value. So if I wanted to create a number slider between 0 and 5, so I can do 0 and then I put the default value. Let's say we set that to 1 to 5. This would create a number slider that goes from 0, 1, 2, 3, 4, 5. But this actually is just integers because we put it that way. If we wanted to create finer control and have more decimal points in between, you just add more decimal points. However many you add here is how fine your number slider will be. Ours right now has 3 decimal points. So we just connect that to it. Now we can control the direction of our point. Again, we just need to copy this by holding, clicking and dragging and then pressing Alt. We want to copy the same point, but we want to move it in the opposite direction. So we already have a vector, that denotes like the amount and the direction. To change the direction, we just type in reverse and we choose reverse a vector, this one. Connect the unit vectors to the vector input, and then this now goes to the motion instead. So we have our points that go up and down, and we also have our start points and end points. So to create the arc, there's a bunch of ways we can do this. If you go up to curve here, you'll see that in your spline there's different types of curves. There's a Bezier span, interpolate, NURBS curve, polyline, which is actually just lines, and interpolate. This is the one we want. It requires the vertices, degree, periodic, not solid. You don't really need to worry about this for now. All we need really is the vertices, and we need to put them in order. So if I go into, also we're going to use the merge block to, make a list of our points, because vertices only takes lists in. And the first item that we want, let's say this here, is going to be our first item in the list. So we just drag that into data. The next point for the top chord will be this one up here. So I find that, it's this one, put that in, and it automatically creates a second, a new entry for the next point to go in, and that's going to be this end point here. I can get rid of this extra one just by clicking minus there, and now we have our merged results. If I drag that into the vertices, you'll see it creates an interpolated arc, which is what we want. So again, I'll just duplicate that. Duplicate the merge as well, and instead of the middle point being at the top, I'm just going to take this middle point, which is at the bottom here, and drag that into the D slot, the second slot, instead of the other one, so it'll automatically disconnect it. Now we have the 2 bottom and top chords. What else? So now I think the next step we should be doing is to create these vertical members. Since the top and bottom chord are the same size, same length, if we divide up the top chord and the bottom chord the same amount, we will have verticals that are basically just parallel to each other, and they're all straight up and down. So let's divide that. So divide curve is what we're looking for. This one. We just feed it the curve, and also by default this count value is set to 10, so it creates 10 different segments. It divides the curve 10 times. To have more control, we can create a slider. We'll say it goes up from 0 to 10, and we'll connect it to count. By default, like if I set it to 1, you'll see it really doesn't create any points. If we hover over this, there's actually 2 points, which are at the ends, and because there's only 1 segment here. If I set this up to 2, now it creates 1 more point here, and it divides this curve into 2 segments. So that looks to be a good amount. You know what, maybe we need even more than 10, so I'll increase that to 20. That's a good amount. Yeah, so we have chords on points on the top. So we'll do the same for the bottom. We'll use this curve here as our input for a divide curve, but we'll use the same number slider because we need the values to be the same number of divisions at the top and bottom. So right now, if I go again into line and just drag and drop these 2 points, we'll create our vertical members. That's fine. Next step would be to create the diagonals. And if you look, the diagonals, the points on the top and the points at the bottom for the right diagonals, let's see if I have this open still. This might be useful. Yeah, whoops, okay. So the points on the top here, we're going to be ignoring this endpoint here. So if you remember, there's 2 curves here and each of them are divided up. So there's 2 points here that are overlapping. To create our diagonals, we actually, on the top chord, let's create the blue diagonals first. So we ignore the first one, we keep the second, we keep all the rest except the last 2. To isolate these points, basically to get rid of some of them, we can use a block called call index. So when you type in call index, there's a bunch of them. You can call different things, but what we want is call index. There's also a call pattern, which might be very helpful for trusses that are slightly different, like this one here, like the Warren truss. When you're alternating between the points, that might be useful there. So we're going to be taking the call index, and on the top chord we have all of these points. So that's our list that we are calling from. And the indices, if you just type in panel, we're going to put in a number through a panel. You can either type in panel and get a panel like this, or you can double slash and get a panel that way. So if I just put in 0, because the point here is actually the index of that point is 0. And you can see that better if you use point list. So if you type in point list, you'll get this. We'll connect up the points to this block. And right now the font size is very small, so I'm going to increase that. You'll see that the first point is 0 and it goes up to 13. Yeah, so if I just put in a 0 into our index, call index is now happy, it's working properly, and you'll see that this is no longer selected, it's no longer green like it was before. The rest of them are because we only called the first index. To, again, look back at our drawing here, we actually need to call the first one and the last 2. So we could be tempted to, just write 12 and 13 into this list to call the remaining points that we need to call, and you know what, that would be fine, and I'll do that right now. But first I'll do it like this. I know this is going to give me an error. I just wanted to show you something. So if I do this, it looks proper, right? But if you look back at a panel that is a proper list like this, you'll see it has like numbers on the side and it's like ordered neatly and it's got like alternating colors. This is a list, like a multi-line panel. But this one here is just a standard panel, and our call index is not happy about that because it's saying it's failed from text to integer. To fix that, we just right click, go to multi-line data, and now you can see that it's got numbers and it's alternating. It looks similar to that multi-line panel. Our call index is now happy again, and if we look closely, the last 2 points are missing from our point selection, and that is what we want. But the problem with this method of just typing in these values directly is if we change the number of vertical members we have, you'll see that the ends are no longer excluded, but what else is that now your 12th and 13th are at the middle section here, and they're again excluded. So to fix that, we actually have a way to refer to the end of the list just by using negative. So if you remember, this is 0, and if you think about it, if you were to go into the negatives, you would actually come up on the other side. So -1 would be the end, and -2 would be the second from the end. One thing to note is make sure you don't have a empty space, like a new line at the end, because if you do, you'll get an error. You need to make sure there are no empty lines at the end of your list. Okay, I'm going to hide this for now because it's a little distracting. So what I'm doing here is I'm just pressing the middle mouse button, and this will give you a lot of options to disable or enable the block, or I can just simply hide or display it. I'm just going to hide it here. One more thing is when you start up your Grasshopper, your blocks may look different than mine. So if you go into display, draw icons, that would give you icons instead of names. Draw fancy wires, that just gives you a little bit of like those fancy wires. That's not much to worry about. Draw full names is another thing that only really appears. So like it's what I like to use is I turn off draw icon so I can read the names, and I also enable draw full names so I can get a better idea of what these inputs are asking for. Another thing to turn on, if you go to Canvas widgets, make sure all of these are on. It's very helpful, especially this profiler, which will tell you how long your script is taking to, like each block is taking to run. These blocks are very, very fast, so it's not even mentioning how long it's taking. So we won't be really seeing that until we start working with solids later down this tutorial. Where were we? So we have these points on the top that we've isolated and picked specifically. Also, now we can change our number slider, and since we're using negative values here to refer to the bottom, the end, it's still going to remain. Okay, so that's all good. We're going to be creating now, or actually selecting the points from the bottom here, and the points from the bottom we need are basically, if you look, it's like in reverse. So we ignore the first one, took this everything except the last two. If you look at this, we ignore the last two, and we take everything except the last. So it's kind of like flipped, if you can kind of like see that. An easy way then to use the same panel but flip our list, that would basically, so if you just right click on list here, reverse, then you'll get, also we need to make sure we're using the points on the bottom here instead of the top. So you'll get that basically we ignore the first two and the last only, similar to how we have here. We ignore the first two and the last. So yeah, that gives us the points that we need. Now we can just straight up connect it to a line, but you'll see something interesting happen. And you might see this happen later down the road when you're not intending for this to happen. And to fix that, all you need to do, like this star effect, because why this happens is the ordering of your lists are reversed. So since I reversed this list here, this is now 0, 1. So if this is, sorry, if I'm talking about this list here, so this is 0, 1, 2, 3, yeah, right? This one here, however, this is no longer 0. This is actually, like, this is 0 here. So it goes 0, 1, 2, 3, up until 12, I believe. So since I flipped this here, I have to flip it again, and that will give me the diagonals that I'm looking for. Do the same thing for the other side. I'm going to be using, so this here, these two are for, let's group them. Also, if you just do Control G while selecting blocks, you can group them. You can add a name to your group. So I can say right diagonal. Yeah, there's also ways you can highlight it, just whatever you prefer. This keeps things organized, and it's always helpful to keep things organized, especially when your code looks like this, with like blocks and wires. Yeah, so this is our right diagonal. To do our bottom, the other diagonal, it's basically, again, just the logic is reversed. So we'll create these two column indices. The first one goes to the top, and the second one goes to the bottom chord, and we're going to be reversing this one. Actually, I think we're going to be basically doing the opposite, yeah. Same thing, we're going to connect it up to a line. Since we reversed this, we have to reverse this as well. Connect it up, and we have our diagonals that go the other way. So at this point, we're basically done with a single truss, a single lenticular parabolic truss. It looks very similar to this. I'm not going to add this part here. I don't actually know if it's part of the truss. I feel like it is, but I'm going to leave it at this. Now we can move on to, actually showing this thickness of the line better. So right now they're just lines, right? Everything here. We're going to be, again, using the pipe component. So if I just type in pipe, that gives you this. It requires the curve and the radius. By default, when you just drag it into a curve, the radius is set to 1 meters, and that's really big. So we're going to create something much finer. So 0.001, and let's say it goes up to 30 centimeters in radius at the maximum. So once I connect that, now you can play around with the size to get feature needs. So to add more lines, curves, I should say, to the pipe, you can drag and drop, but what you'll see if you just drag and drop it into here is it'll disconnect the other ones. Similarly, everything else that was connected to it, it'll disconnect. To keep the connections that were there previously, you have to hold shift, and you can see on your cursor it's a little green plus icon. When you hold it and you go like that, now you can add on to your input. So yeah, I can keep doing that. So I'll find everything I need to connect up. So I have the bottom chord and the top chord here. Again, I'm holding shift for all of these. And yeah, that gives us our completed truss, a single truss. Now going back into just general Grasshopper, you know what, let me just group this, make it look I'll give it a name. So this is left diagonal. Yeah, so like this looks fairly okay. You can select everything, move around, it's pretty standard. Sometimes you can also, like, if you wanted to line things up, you select 2 of them and you have these like options on the side. These arrows just basically mean line it up to whichever side. So if I click that, it'll line up to the left side. If I click, first of all, it has to be like that. Yeah, you can also line it up bottom top. Just keeps things neat looking, because when you're working with code like this, it's very visual, and if your code is clean and visual, it'll help you out as well. One more thing is, so you have all of these commands that we're typing and we're searching for, like panel. They're all available here. So for example, there's panel. You could find them this way, or you can search for them. So that's an option you have. Also, this bar here, this is like the preview bar. You don't really need to worry about like this. Basically, if you're all the way over here and you don't know where your code is, if you click that, it'll bring you to it. This just adds a named view. I don't exactly know what this does. I haven't used it. I feel like it just creates a named view of your components. I don't know why you'd want that. Yeah, I guess you can sketch on it. But what's most important is on this side here. So we have these 3 options. These are preview options. First of all, I have no geometry in Rhino right now, other than the dots, so I can't actually select them. If I click on this, what it will do is it will hide everything in Grasshopper, so I can't see my Grasshopper geometry inside Rhino anymore. This option will only show a wireframe, and this option, again, is going to shade everything. Finally, there's this option, which it basically, you can exclude certain things. So if I just drag that and click that, wait, let me see. Oh, whoa, something weird is happening. Yeah, so this will only show what's here, if that makes sense. Actually, I don't actually know. I've never used this. This is a new Rhino 7 feature, I believe. I don't remember, or maybe it was in the previous Rhino. I just never used it. But what I feel like it does is it excludes, oh, let me see what it does. Draw preview boundary in canvas to exclude objects. Okay, so it basically shows everything except whatever I draw around. This option here is actually more important. This will allow you to select only things that you want to see. So if you only want to see the pipe, it'll let you see that. If you want to see the dots, the diagonals, etc. Here you can change the color of the red and green that it defaults to, and this is just the quality settings. So now we have our, we'll go back into, we'll turn that off. We have our truss here that's proper and nice. The next part of it would be basically to create an array of trusses along maybe two curves. And that, let's just draw two curves first of all. There's not much you need to change to your script here to have it array into the curves, because the logic, the way we created these curves, this whole thing was created just from these like 2 points, right? So if we get these 2 points to be placed along this curve, like multiple points, then we can do what we want like very easily. So first things first, I'll just import these two curves into Grasshopper. So that would be curve. So if I search up curve, I know I spelled that wrong, get curve, I could duplicate it, set one curve to that, set the other curve to that. We will, to get the points on our curve, we have to use divide curve. So we'll take that. The number, we'll say 1 to 100, 0 to 100. We'll set that somewhere in the middle, and we'll create a copy. And for this copy, I'm just going to use this bottom curve here. I should probably reorder them because left is usually top. Yeah, top, bottom, left, right. Cool. So we have these two points, like an array, well, lists of points. So there's two lists. If you look into it, there's actually like lots of points, and they're in a nice, neat list. We could just connect, now we have these points, right? We could just connect them to the points here, assuming that these points are in order. I drew these lines in the same direction, so they should be, but if you double check, if you want to double check, it's always a good practice, because then you know exactly what is going wrong with your code. So that's 0 over there, that's fine. And this one, that's 0 over there. Yeah, so the lines, the curves are, the points are in order, and they're in the proper order. But it won't immediately work if I just connect up the curves. So you see how it's doing some weird things? That's because when we merge the points here, when you select this, you see how there's so many points selected? It merges it all into a single list. So if you look into this, there's 152 dots, but there's no like differentiation between them. There's like no grouping. What we really want is actually a grouping of 3. So like imagine if you look at this, just it's hard to, I know it's distracting with the curves here. There's a point here, and remember we had a point in the center here, and then we had a point here. So that those 3 points would define a top arc. So what we need to do actually is graft all of our inputs. Future me here, instead of grafting every single input from here, you can actually graft just the input points here so that you get the same effect. Okay, back to the tutorial. Yeah, and that after you do that, you'll basically have a finished product. Like you have an array of trusses that take 2 points, start, and they all look like the same truss. The only difference is some of these trusses are longer than others because of the way because of the distance between the curves. If I close this up, you'll see these, yeah, this truss here is it's hard to see, maybe if I bake it. So another thing you can do to bring Grasshopper geometry into Rhino, you just select what you want to bring in, middle mouse click, and click on this little egg icon to bake it. Now I'm just going to hide everything inside Grasshopper so I can only see Rhino geometry. And yeah, that looks proper. And with that, I think we've concluded our little very quick basic intro to Grasshopper, how it works, how you can find components, you can search for them, how to create panels, you can just /, how to create number sliders very quickly. A little tip I have for you, and this was brought up in the workshop, is if you wanted to hide some of these cables because they're really busy, as long as I wouldn't recommend it, but you can do so if you just go into wire display, you right click on the wire you want to hide, wire display, and you can do faint for a really thin line, or you can just turn it off like altogether. It just gives a little wireless icon, meaning like showing you that it's actually connected to something. And if you click on it, then you can see what it's connected to. Personally, I just leave them all the way it is because it's a lot of work. turning each wire off. But yeah, here's this profiler thing that I was talking about, which we enabled from display canvas widgets to profiler. 146 milliseconds is how long this this took to basically this pipe function to render or to complete. You want to keep an eye out on blocks that take longer than, like, a really long time than they should, and that's just yeah, just make sure they don't go too crazy. Yeah, that's basically it for Grasshopper. There's so much you can do with Grasshopper, and you know, with this assignment, I hope you know, it gives you a good start. And yeah, thanks for watching.